So in this class, we are going to see about the centroid of a composite geometry. So what is a composite geometry? In the last videos, we saw that we only dealt with those kind of shapes. This one. We saw the values of this kind of shape in which only a single geometry was present. Means it was only a rectangle, it was only a square, this is only a triangle or a circle or right angle triangle. So all these geometries were some regular shapes. But if two or three or more than one this kind of shape come together to form different kind of geometry, it can be anything. It can be a circle taken out of a rectangle, or it can be a triangle added on a rectangle, or a quarter circle taken out of a triangle. It can be anything. Means we can see here that these shapes are now containing more than one geometry. Means here I have a geometry 1 which is a rectangle or square, and a geometry 2 which is a circle being taken out of the system. Here also I have a first geometry in which we have a rectangle, a triangle placed over it, and a quarter circle taken out of it. So this kind of geometry, you can encounter many problems like this in your day-to-day life or in your university exam as well. So a composite geometry is one which contains more than two shapes, more than one shape coming together. Now these shapes can be addition or subtraction. So if this circle is being taken out of this one, so this part has become hollow, and if this one is added and this one is taken out, this part has become hollow. So you have to consider this. Now in order to find out this one, we have a formula. We have a formula which says that sum all the areas AI and XI. I starts from 1 to n divided by a sum of all areas. This is the formula. As I told you in the first video, centroid is a point about which the moment of the area is going to be 0. So we have this where AI refers to the area of the geometry. If suppose I am considering this image, so I can write it as A1, geometry 1, I is 1, and x1, which means what is the location of this centroid from this extreme edge. So first fix the reference axis. Once it has been set, you can see that x1, as we have discussed in the last class, it will lie right behind between the axis of symmetricity. So a1 x1 minus a2, because the area 2 is being subtracted. So minus of a2 x2 divided by a1 minus a2. Or for second image, if I am trying to do this, let us mark them 1 and 2. For the second image, this formula will be, remember, a1 x1, 2 is being added, so plus a2 x2, and 3 is being subtracted, so minus a3 x3 divided by a1 plus a2 minus a3. This will give you the value of x bar since you are using the x terms. Similarly, if you will be using y terms, y bar can be given as a1 y1 plus a2 y2 minus a3 y3 divided by a1 plus a2 minus a3. So you can see what I have done here. Areas are being subtracted in the first formula. Let us write the value of y bar also. Y bar, now you can anticipate a1 y1 minus a2 y2 divided by a1 minus a2. So if the areas are being subtracted, you need to use the subtraction in the formula if they are being added. So you can have more than one image, it can be 2, 3, 4 depending upon the. So first responsibility is to define the axis and divide it into some regular shape geometries for which we have already seen for which we already know the location of centroid. Then only you can put the values in the formula 1 x1 y1 x2 y2 x3 y3, something like that. And one more thing, it's about keeping your worksheet clean. So cleaner you will do all these calculations. Since it is all about calculation, the chances of doing mathematical error is very high. So what I usually do, I make a table. So this table will contain rows one more than the number of geometries. So suppose I am drawing using making this table for figure 1. I'll have 3 rows because it is containing 2 geometries. So 1, 2, 3. Now the first column of this table will contain geometry number geo. So we have 2 geometries 1 and 2. Second column will contain area. So area will be, I will write here unit square, whatever will be the unit, that will be the value of area. So A1, A2. Then we have the third column which will be writing XI, and it will be again unit, and it will be the location of the centroid of that particular geometry with respect to the reference axis. And then we have YI, and its unit will be also whatever is the unit of the problem. And now you can see we have made our table. So similarly, if you want to make for table for geometry 2, you are simply adding a third row which is marked down as 3. So xi adjacent to 1, it will refer to x1, it will be x2, it will be x3, y1, y2 and y3, and this will be a1, a2 and a3. So all things that you require to put in the formula is placed right in front of you in a well-tabled column, and you can use them. So a1 x1, a2 x2, a3 x3, then a1 y1, a2 y2 and a3 y3 divided by a1 minus plus a2 minus a3. Whatever is the geometry, whatever is the problem definition, we can proceed. So that's about centroid of composite geometry. See you in the next class, which will be our numerical solving session.